We have had several lessons on how to factor. Why did we do that? Well, so we could learn how to solve quadratic equations. The very beginning of class, we looked at linear equations. You just had the variable x raised to the first degree. Now we're going to move to second degree equations. A quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals to 0. We have an x squared term, x, and a constant, quadratic. So for example, this is a quadratic equation where, if you look, a is 4, b is -3, c is 2, and it's equal to 0. It's in standard form. Now this one, not equal to 0, but if I subtracted 75 from both sides, set it equal to 0, the only thing that it's missing is really the x term. And that's okay if it's missing something. That's still quadratic because we have x squared. That's what we're looking for, is that second degree equation. On this next one, I could move the 5x by subtracting 5x, subtracting the 3, setting it equal to 0, and again I have a quadratic equation. That's what we're going to be solving by factoring. Another thing we need to review is what's called the zero product property. It says if I multiply two things together and get 0, then one of the things I multiplied by had to be 0, or perhaps both. Why is that important to know? Well, if I have 7 times x is equal to 0, what does x have to be? It has to be 0. If I have x times y is equal to 0, the zero property says either x has to be 0, or y has to be 0, or both of them have to be 0. In order to multiply to get 0, one thing has to be 0. Very important. How do we solve those quadratic equations? We're going to go through these steps. First one is we're going to set the equation equal to 0. We're going to put it in what I call standard form, descending order equal to 0. We're going to factor completely. That's why we've learned all those factoring techniques. Then we're going to use that zero product property to set each factor equal to 0. And we're going to solve each equation that we produced in step 3. We're going to solve it, and then we're done. So let's go through those steps. Looking at number 1. Well, it's equal to 0, so that's done. It's also factored for us, so we don't need to do that. So the third step is to use the zero product property to set each factor equal to 0. Alright, I have 1, 2, 3 factors. Let's set them each equal to 0 because all 3 of these are multiplied together to equal to 0. So one, both, or all 3 have to equal to 0. So how do I solve? I divide by 4. So this is a review of like lesson number 1 almost. I'm going to add 1 to both sides. I'm going to subtract 6. So I don't have one answer, I have 3 answers. And you could check by plugging in 0 here, here, and here, and you'd get 0. You could also plug in 1 here, here, and here, and you would get 0. You could also plug in -6 here, here, and here, and you would also get 0. All 3 of those would work. Let's look at number 2. It's equal to 0, so it's in that standard form, but this time I have to factor it. So it's a trinomial with a leading coefficient of 1, so I know x times x. Remember, we want to know what multiplies to get -21, but adds to get -4, -7, and +3. Then we set each factor equal to 0, and solve. So I'm going to add 7 and I'm going to subtract 3. So I have two answers for number 2, -3 and +7. Look at number 3. That's not a trinomial, but it still is in standard form. It's still equal to 0. We just don't have a constant. So we've set it equal to 0. Now I need to factor it. It's not a trinomial. It's not the difference of two squares. GCF of 2x. So if I divide both by 2x, that's going to give me 3x minus 1. Then I set each factor equal to 0. Dividing by 2. Now here I need to add 1 and then divide by 3. And I have two answers, 0 and 1/3. And again, you could come back here and check by plugging in 0. That's easy. Plugging in 1/3, probably not as easy, but I'm pretty sure those are the correct answers. Okay, so number 3, we didn't have a trinomial. We had ax squared plus bx plus c, and my c was missing. It was 0. On number 4, we have ax squared plus bx plus c equals 0, but I don't have that bx. That's okay. It's still quadratic because of the x squared. It's equal to 0. I still need to factor it. It doesn't have a GCF. What kind of factoring? It's not a trinomial. Squares. It's the difference of two squares. So I need 2x times 2x to get 4x squared. 3 times 3 is 9. 1's plus, 1's minus, those conjugates. Then I set each factor equal to 0. So here I'm going to subtract 3. And I'm going to divide by 2. So I get -3/2. Over here I'm going to add 3 and divide by 2, and I get +3/2. Now the next few examples you can see are not equal to 0. They're not in standard form. So you've got to work a little bit more. We need to get it equal to 0. So let's put everything on the left side. So I'm going to subtract 2x squared. I'm going to add 6x. And I'm going to subtract 3. Now keeping my equal sign, that gives me that 0. That's what I want. And I have 12x squared minus 16x plus 5. Checking my arithmetic, I think I got that right. Now I have to factor it. It's a trinomial, not a leading coefficient of 1. So I'm going to write down my factors of 12, write down my factors of 5. That's the good news, 1 and 5. And just like on my trinomial lesson, I'm going to start with my smaller numbers, see if it works. Let's see, 1 and 5. I got to check. I'm trying to get -16x in the middle. So let's see, that's 4x, that's 15x. That's not going to work. So let me reverse the 5 and the 1. I'm not going to give up on that yet. So let's see, that's 20x, that's 3x, that's still not 16. Alright, so 3 and 4 don't work. And no, it can't be prime. I'm not going to give you any that says solve and it's prime. Alright, let's see, 5 and 1. So that's 30, that's 2. No, that can't be. So let's flip-flop those around, the 1 and the 5. So that's 6x in the middle, and the outside gives me 10x. Oh, yay. And I need them both to be negative. That gives me -16. And just checking my signs, a -1 times a -5 is a +5. So that's why we have to get pretty good at factoring, so it doesn't take us forever. Am I done yet? No. I had to set it equal to 0. I finally factored it. Now I set each factor equal to 0 and solve. So I'm going to add 1 and divide by 2. Here I'm going to add 5 and divide by 6. I'm saying what I'm doing, I'm not necessarily writing down everything, and that's okay. Number 6 kind of looks like number 5, but I've got all this multiplication. So I need to multiply this out. So I need to FOIL it out. So I'm going to bring down the left-hand side. Let's see, I'm going to get 2x squared minus 10x plus 3x minus 15. I'm going to put my middle terms together. Now I'm like back on number 5. I want to move everything to one side. So I'm going to subtract the 2x squared. I just move it to the side that keeps my x squared positive. Okay, so what do I have? I have 5x squared minus 12x plus 7 equals to 0. Again, I'm just checking my arithmetic. That is all 0. I think I'm good. Now I have to factor it. So I only have one choice for 5 and only one choice for 7. Thank goodness. So 1x times 5x. Now where do I need to put that 7? If I put it there, I'm going to have 7 times 5, which is 35. That's just too big. So let's put the 1 here and the 7 there. So that's going to give me 5x in the middle. Those are 7x. Make them both negative. Checking my signs. I think I'm good. Set each factor equal to 0 and solve. So I'm adding 1. Here I'm adding 7 and dividing by 5. Again, very long. Haven't done anything quite this in-depth in this class yet. You can do it. Number 7. Now does that look like number 1? Is it already factored for us? Well, yes and no. It's not equal to 0. And we don't have any property that says, ooh, if they multiply together and be -1, each of them has to be -1. No, no, no. That only works if it's equal to 0. So we still need to multiply that out and set it equal to 0. So let's just start. Oops, that's a -1. I put those together and I have 18x squared minus 39x, and then I'm going to add 1 to both sides and I get a positive 21 equals to that very, very, very important 0. Now you're going, oh, those numbers are so big. Yes, they are, but they have a GCF. What is that GCF? 3. So if I divide all of these by 3, that's going to give me 6x squared minus 13x plus 7 equals to 0. So now we need to factor that trinomial. So again, my choices for 6 and my only choices for 7. Don't forget that 3. So let's see. If I stick with 2 and 3 and 1 and 7, will that work? Let's see, if I put my 7 here, my 1 here, that's going to be 21, that's going to be 2. That doesn't get me 13. So if I put my 1 here and my 3 there, oops, 7, sorry. That's 3, 14, 14 and 3, nope, that doesn't do it. So it's not 2 and 3. And really, I probably should have seen, I should have used 1 and 6 and 1 and 7 because 7 and 6 make 13. Maybe you saw it and I didn't. Alright, so again, I don't want to put my 7 here because that would multiply times 6. That would be too big. So I'm going to put my 1 and 7, make them both negative. Check it out. Does that work? Yes, it does. Not done. Now in your notes it says set each factor equal to 0. Well, if I set this equal to 0, then I set this one equal to 0, and I set this one equal to 0, I need to solve for x. First of all, is there an x there? No. Does 3 equal to 0? No. So that doesn't help us as far as our solution. So any factors that don't have an x or your variable, you can throw them out. And that is why, because you don't have a true statement. So here I'm going to add 1 to both sides. Here I'm going to add 7 and divide by 6. So I can't even hardly fit it in the screen that there was number 7. Look at all that work I did for those two answers. Number 8, last example, longest problem. Okay, so again, it's not equal to 0. We have to FOIL all that out, get it to one side. It's a lot of work. Let's just dig in. So we're going to FOIL. FOIL on this side, meaning using my distributive property. Then I'm going to collect like terms. Putting my middle terms together. Then I need to set it equal to 0, and again I like my x squares to be positive because it's easier for me to factor it that way. So let's see, that's going to give me 1x squared plus 6x. Oh, that's 0. And of course that's 0. Thank goodness. An easy thing to factor. It's not a trinomial, but it at least has a leading coefficient of 1. How do I factor that? Just a good old GCF of an x. So divide each by x. Left with that, I want to set each factor equal to 0. And this time, that is an x, so I want to set it equal to 0. That is a solution. That's not the same as just a number. That is an answer. And here I subtract 6 on both sides. That's what I've got.